Okay, prove that the difference between two consecutive square numbers is always odd. I love proof. It's just, people don't realize it, but it's so important. The fact that maths, is kind of the same subject. A lot of what we're taught at school has been the same for the last, thousands of years as such. Maybe not thousands, but hundreds of years. Is because these things have been proven. They will still be true in 1,000 years. Okay, this statement will remain true forever. So it's quite interesting as well to show that it's true forever. Let's have a go. So the difference between two consecutive square numbers. Now what you can, one starting point for this is to find the difference between two consecutive square numbers. So 3 squared is 9, and then a consecutive number to that would be 2 squared, which is 4, and I get 5, and I can see it works, but that is not a proof because I've only tested it for one case. So what I need to do is test it for every single case. There are an infinite number of cases. How can we deal with that? Well, we can think first of all about what square number is. So I'm just gonna leave that there, my working. A square number is just a whole number that's been squared. So if I want to find two consecutive square numbers, well, the one after this is going to be x plus 1 squared, and the one before it would be x minus 1 squared. Okay, and that will give me two consecutive, because that means next to square numbers. So if I want to find a difference, the difference is always positive, and what I'm going to do is I'm going to find the larger one, so x plus 1 squared, minus the smaller one. And this is the crucial bit in your proof, basically, constructing this algebraic line and then following it through to try and get an odd number. So x plus 1, so I might write as a little statement, difference equals, that I do, and then I'm going to expand this out. This is going to become x squared plus 2x plus 1. I've done that quite quickly because I've done this many times, but I'm basically multiplying out x plus 1 times x plus 1. Don't forget about this 2x, and we can do our crab clause, x squared, x, 1. That's what that gives. Done. And then I'm going to minus x squared. And we're nearly there now, so I should probably put an equal sign in. The x squareds are actually going to cancel, and we're going to be left with 2x plus 1, which is odd. Okay, because I have an even number, a multiple of 2, and then I'm adding 1 to it. I don't need to say any more. That's a generally accepted form for an odd number. If it ever says like use an odd number, use an even number rather, you write it as 2x or 2n. If you've got an odd number, you'd write it as 2n plus 1 or 2n minus 1. And then just to finish off, let's just write proof complete. Just good to say I've done it.